Measures of center and variation, part 2. So we're up to example 3, and it says 2 reality cooking shows. Select 12 contestants each. The ages of the contestants are shown in the tables. Find the range of the ages for each show. Compare your results. All right, so what we're doing is we're trying to find the range. Remember, the range by definition is the difference between the highest and the lowest value. So the first thing you may want to do, so let's hit show A. Let's put these in order. So you can see show A goes 19, 20, there's another 20, 21, 22, 25, there's 2 27s, 2 29s, a 30, and a 31. All right, so that's show A. And show B, if we put these in order, again, we have 19 is our lowest. So that's our smallest if we're putting them in order from least to greatest. So 19, 20, 21. Again, we're looking at show B. All right, there's a 24. There's a 25, another 25. There's 2 27s. There's a 32. And then 48 would be the last one. And that probably would be considered an outlier as well because it's substantially larger than the other one. But we're not looking at outliers right now. We are looking at finding the range. All right, so the range again is the difference between the highest and the lowest. So for show A, we're going to find the range. We're going to do the highest is 31 and the lowest is 19. So 31 minus 19 equals 12. All right, and since we're looking at the ages of contestants, it would actually be 12 years. So the range in years from the youngest contestant, 19 years old, to the oldest contestant, 31 years old on show A. So that range would be 12 years. Show B. So we're going to have a range of ages as well. This time we're going to go from 48 to 19. So 48 minus 19 equals 29 years. So this one, the range is larger. All right, it says compare your results. All right, so the results are pretty similar, except this one has an outlier, which really skews the range. I say skew. It's not, the range is what it is, but it changes the result by quite a few years, having that one number that's much larger than all the others. So it really shows you that for show B, the range in ages are simply more spread out, at least when you include the 48. Example 4, modeling real life. All right, so it says consider the data in example 1. A manager considers increasing all hourly wages by either $1.25 or 10%, which increases results in a greater mean hourly wage, which increases results in a greater range of hourly wages. All right, so which increases results in a greater mean and which increases results in a greater range. All right, so this is students' hourly wages. If you look, this is the same data from example 1. So it says consider data from example 1. So let's go back and just pull what we've already found. All right, so in example 1, here's the student hourly wages, and we found the mean to be $9.65. All right, so the mean, again, x bar is the same as the mean. And $9.65, I believe is what I said. All right, now, what was the range? The range is the difference from the highest to the lowest. So the highest amount is $16.50. So we've got $16.50 minus $8.25. $16.50 minus $8.25 is $8.25. All right, so now we know the mean and the range of the original data. Now, it wants us to look at what happens if the hourly wages are increased by $1.25 each. All right, so if each number in this data set is increased by $1.25, and then I take all of those, add them up, and divide by 8, that means the mean is also going to increase by that same amount. So what I can do is just add the $1.25 to the mean, and that gives us the mean of the new data set. All right, so 965 $9.65 plus $1.25 equals $10.90. So that would represent every student getting $1.25 an hour raise. The range would be the same. The range wouldn't change because if the highest number and the lowest number both increase by $1.25, they're still going to be the same distance apart. Okay, so hopefully that makes sense. All right, so the mean, 1090. The range is still going to be 825. All right, so that's with an increase of $1.25. So this is a $1.25 increase. All right, now I want to look at it if I increase by 10%. Okay, so remember, if I multiply anything by 1, you get the same number back. So for instance, $16.50 times 1 is $16.50. So if I want to increase by 10%, I have to do 1.1 or 100% plus that 10%, which is 1.1 as a fraction. So if I want to do that, I'm going to have, this is 10%. All right, so I've got my mean. The original mean was 965. And I want to multiply that by 10%. So 1.1 represents a 10% increase. Again, remember 1 times 965 is 965. So I want it to increase by that 10%. All right, so if I do that, let's see what we get. 9.65 times 1.1. Remember, if you do just the 0.1, it's going to give you 10% of this value, which would be a smaller amount. You obviously don't want to make less money. So about 1062. So say it's about $10.62. That's with the 10% increase. All right, with the range, next would be the range. All right, so the range was 825. And we're going to increase that by 10%, which again would be 1.1. All right, and that's going to be about 8.25 times 1.1. And that's going to be about $9.08. All right, so this is with the 10% increase. All right, so we can see the average for the $1.25 raise would take the average up to $10.90. The average for the 10% raise is $10.62. So that means the greater hourly wage for the mean would be the $1.25 raise. Then if we look at the range, it's got $8.25 is the range here. So that's the difference from the highest to the lowest. If we multiply that by 1.1, that's multiplying the top number by 1.1, multiplying the bottom number by 1.1. But if we multiply that difference, it's still the same. So that's what we did. We just multiplied that range by 1.1. And that shows us now that the range is 9.08. So the range for the $1.25 raise would still be $8.25, and the range for the 10% range would now be 9.08. So you can see that the 9.08 is greater than the 8.25. So the hourly wage that's greater, so the increase results is greater for the range for the 10%. So you can see that depending on whether you're looking at the average or the range will depend on which way you want to go with that raise. So I guess it depends on whoever's given the raises will have to determine whether they're going to look at the mean or if they're going to look at the range. I would think you would want the mean to go up. That would be more important than the range. The range means that there's like a bigger difference in the lowest paid person and the highest paid person. So I don't know that you want that range when you're talking about salaries. If you want that range to get bigger, usually if you got hardworking employees, you would want like the mean, the average salary to all go up together, just kind of keeping the peace at work. All right, that's all for measures of central tendency or measures of the center. So if you have any questions, please let me know.